Welcome. In today's lesson, we're going to be looking at adding fractions together. All right. So the thing here, what we've got is we've got a third plus a quarter. So how do we do that? Now, if they had the same number at the bottom, the denominator, then we just simply add them together. All right. So I know you've done some of that. Now, we did a paper folding activity in class, and I just want to show you how this works. So if we had a third and a quarter, so to make a quarter, we have to fold this into 4 bits. So we halve that, and halve that again. All right, that's our quarters. So if we shade a quarter, then we're going to shade this area here, something like that. All right, so that's a quarter of our shape. And now we're going to break this into thirds. So a little bit tricky to fold, but get the idea. So that's supposed to be all equal bits for it to be fractions. Now, if I want to shade a third is simply going to be 1, 2, 3, 4 squares. So I would need to shade, there's 3 squares there, and then I have to shade another square. So what I'm looking for, if I count the number of squares that are shaded over here, I've got 1, 2, 3, 4, 5, 6, 7. So I'm thinking the answer is going to be 7 out of how many squares do we have? Well, we've got 12 squares. 4 by 3 is 12 squares. Okay, now obviously you don't want to be folding paper every time you do one of these questions. So how do we do that algebraically? All right, how do we do that the more traditional way? Well, what we're thinking here is, what's a number that 3 and 4 go into evenly? Well, the number is 12. All right, so the number's 12, so I can write 12 there in the bottom. And then I'm adding this order. When I'm taking it, doesn't really matter. I'm doing the same process. What would I need to times 3 by in order to get 12? Well, I have to times that by 4. So then I have to times the top number by 4, so that will be 4 times by 1, which is 4. Do the same thing for the 4. What would I need to times 4 by in order to get 12? Well, I have to times that by 3. So that's going to be 1 times by 3, and that's going to be equal to 7 on 12. I actually quite like that method. All right, some other people like this method, and I'll just show you this. And you've got to find a way of doing this yourself. So a third plus a quarter. So some people like this, and they go, oh, the number's 12. So what I need to do is I need to times that by 4 over 4. Right, and so therefore that's like timesing by 1. And here I have to times that by 3 over 3. And that's like timesing by 1. So now when we do our work over here, all right, so that becomes equal to 4 on 12 plus 3 on 12, which will give us an answer of 7 on 12. So it doesn't really matter which way you do that. The process will get you the same answer. You're just going to find a technique that's going to work for you. Now, interesting, we talked about multiplying fractions before. If I was doing 1/4 times by 1/3, then that's going to be equal to, well, we times the top numbers together and we times the bottom numbers together. How does that work with our grid? Well, we do the same thing here. If I did a quarter, right, so a quarter of that would be equal to that shaded bit there. If I did a third, I'm multiplying now. I'm multiplying this way here. Right, then the square that's in common is this square here. Okay, that's the common square where we cross over. So then that's how I get my 1 on 12, which is actually quite a nice little activity, I suppose. Let's move on to something that's a little bit trickier. Not much trickier, but a little bit trickier. So let's come down to the second example, and we'll do this one here. Right, so let's say we had 2/5 times by 1/3. All right, so we'll do it graphically again. So what it means is I've got to break this into fifths. So I'm just going to estimate there. So 1, 2, and remember it's a fraction, so these should be all equally spaced for them to be 2/5. Now I had to shade that. then what this would look like would be 2/5. I'm going down this way. Right, so I'm going with 2/5. I'm shading 2/5 of that up. And it's probably even good to write a fifth in there. The next bit, I've got to do times add a third. So again, I'm going to break this into thirds. And again, they should be equally spaced. They're not, but you get the idea. So a third of that would be 1, 2, 3, 4, 5 squares. So I actually have to shade 5 squares. So I've got 3 here. All right. And I've got another 2 that I have to shade. So that technically should be 3/5, 2/5 plus 1/3. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's going to be 11 out of how many squares are there in the box? 15. All right, so that's the technique there. All right, now if I do that the same way as I did before, okay, so I look at my common number here as being 15, 3 times by 5, lowest number that both of them come into. They call it the lowest common denominator. It's just the number that both of them go into. And then what do I need to times 5 by in order to get 15? 3. Right, so there I have to times my 2 by 3. So 2 by 3 is 6. And then I have to add, well, what do I have to times 3 by to get 15? Well, that's 5. 1 by 5 is 5. So then that's going to give me 11 on 15, which is our answer. All right. The other technique I showed you, we've got 2/5. Okay, 2/5, and then we're going to add 1/3. All right, so this will work for any particular case. Now I have to times that by 3 on 3. Have to times this one by 5 on 5. So then that becomes equal to 3 times 2 is 6. Bottom line is 15. Plus 5 times by 1, which is 5 on 15, which is going to give me 11 on 15. Got that idea? Now, the next example, I suppose, is also to look at if we had to multiply those. So we had 2/5 times by 1/3. Then we would do the same thing as what we did before. So 2/5 is shading these two lines here. That's 2/5 of that object. And then we're going to times that by 1/3. So 1/3 would be this shaded region here. So the common area for that is going to be these two squares, isn't it? So if we were timesing those two things together, we would get an answer of 2 out of 15. All right, looking at that scenario there. Anyway, I hope this makes the process quite straightforward. Well, it doesn't matter what you're doing. This process works for every fraction that you'd ever have to do. Right? So you've got to find a technique that works for you. Obviously, if you need some extra help, you need to come and talk to one of us teachers.